Classifications on differential equations. In this section, I'm going to take that of the order and then the degree. As already stated here, the order refers to the highest order derivative. So we are looking at the derivatives in the equation, not the unknown function, but its derivatives. So we're looking at the y primes, the y prime primes, and then so on and so forth. Let me hint that this video will be more of the ordinary differential equations from now to the last classification, but it applies to PD as well. Okay, and then the degree here is the power or the index, or someone say the exponent of the highest order derivative. So I have here with me, if I'm able to select the highest derivative, I look at the power or the index of it, and that is the degree. So let's quickly go through some examples here. I have 4 examples. So example 1 is an ODE. You agree with me, it's an ODE. The order here, I'm looking at derivative, not this one, but there's a derivative here, and then it is of order 1. The degree means if I have a bracket here, the power is 1, which we don't write, so the degree is 1. Example 2, there's a derivative here, there's a derivative here. We want the highest order derivative. This one is not part. Here has order 1, here has order 2. So the highest becomes order 2. The degree, if I have, so let me write it here, 2. If I take a bracket around this highest order derivative, it has an index of 1, and hence the degree is 1 here. Example 3, I'm not looking at this guy, I'm looking at the derivatives. So order 2, the highest order is 2. If I have a bracket around it, the degree is 1. Now take note that the degree is not always 1, but in these examples, the exponent is 1. That is all. Now let me take this another example here. Straight you can tell order 1, because the highest derivative is here, and then degree is also 1. The last example, the order will be 2. I guess you can do that. This is order 1, this is order 2, the derivatives. Degree here is also 1. It's just unfortunate that for this example, all my degrees are 1. And there'll be other examples where the degrees are 2 or 3 or 4 and so on and so forth. So you take note. Alright. Now let's look at the special cases. I had to skip this definition. Now to find the degree, there's one more condition to add. Let me use a green pen. This must be cleared of all fractions. That is, if there are fractions, it must be cleared before we can tell the degree of the differential equation. In this, all my examples, there are no fractions to them, but let's look at a special case. In example 1, I can easily tell the order. This is not part. I have a derivative, you have a derivative here. The highest derivative here is 1, here is 2, so order 2. But the degree cannot be 3 on 2 because I see 3 on 2 here. No, there are fractions that need to be catered for. So to do away with the fractions, I can multiply through by 2 at both sides of the equation. If I do that, then I have y prime prime cube minus y prime raised to the power 1, which I don't write, is minus y to the power half. Sorry, if I'm multiplying through by 2, this becomes square is equal to 0. Hence, I could easily tell that the order here is 2, and then the degree is 3, because the degree is the power of the highest derivative. Okay. Example 2, I could easily tell that the order is 2 because the highest derivative is here. Here is 1. But because of the fractions here, I must be able to cater for it before I can tell the degree. How do I cater for the fractions? I have to multiply through by 3 by 3 here by 3 here. And so the new equation becomes, I could have y prime prime cube plus y prime to the power 1 plus x to the power 3 on 4 equals 0. Don't be bothered here because this is the independent variable. It is not a derivative. Alright. So the order here is still 2. Now the degree of this becomes what? 3. So we see the differences here. Okay. There's another special case where the degree is unknown. Degree unknown. But the order will be known. And how do I tell that? In the instance where, let me use a red pen to emphasize it. In the instance where I have transcendental functions of my derivative, transcendental function of the derivative. So example, I have ln of y prime, I have cos of, it can be the double prime, I have sine of the derivatives, I have exponential of the derivatives. These are transcendental functions. I can have the log of, let's say, y prime prime prime, and so on and so forth. These are the transcendental functions. In the case of such, the degree does not exist, but the order will be known. Okay, so let me take an example here. If I have y to the power iv plus sine of y prime is equal to 0, quickly, the order here, the highest derivative, so I have order 1, I have order 4. The order is 4. But the degree, you'll be tempted to say the degree is 1, because if I take a bracket around the highest order derivative, the index is 1. No, because we have, let me change the pen to help with the emphasis. Because of this function here, the degree does not exist, or is unknown. Okay. Another example, if I have let's say d square ds plus cos 2x plus sine 3x is equal to 0. What is the order here? The order is always known as the highest derivative, order 2. The degree is a 1, or it is unknown. In this example, the degree is 1. Even though I have the cos as a transcendental function, they are not on the dependent or the derivatives. The x is the independent variable. The transcendental functions must be on the derivative. So assuming I had 2y prime here, then I can say the degree is unknown. But in this case, the degree is 1, because if I take a bracket around this guy here, the exponent is 1. So take note of the special cases when defining degrees and then the orders. Alright, so I hope these examples has helped. You can quickly go through any other examples and then you'll be fine. Don't forget, degree must be cleared of all fractions, and in the case where there are transcendentals of the derivatives, what did I state that here? The degrees is unknown. So that is it for order and degree. In the next video, I'll take the linearity. All right, thank you very much.